How do we talk to satellites in space? And what role do communication satellites play in our daily lives? Let's find out in this episode of How to Build a Spaceship. Honeywell Aerospace Mission Control, do you read?
Roger, reading you loud and clear, Mission Control.
Satellites are an integral part of our modern lives. From communications to navigation, Earth observation to space weather monitoring, we interact with Earth orbiting satellites multiple times a day. There are hundreds of communication satellites in Earth orbit. Without satellites, a lot of simple things we take for granted every day would no longer function. Communication satellites work by receiving signals from Earth. These signals fade on the journey of up to 36,000 kilometers in orbit, so the satellite has to amplify the signal on board before transmitting it back to Earth. Multiple Honeywell components play a key role in this process, including switches and multiplexers. Can you explain how satellite switches work?
Well, a satellite switch, it changes the direction of energy on a satellite, sort of like a railway track, moving the train from one track to another.
And why do satellites need switches?
One of them is to move information, move data around. For instance, you might want to have a lot of data at the East Coast in the morning, the West Coast in the afternoon, so you move the beam. Another reason is for redundancy. Things can wear out on the satellite, and what the switches will do then is they'll switch on another piece of equipment.
So what is a multiplexer or a MUX?
A multiplexer is a piece of equipment on a satellite that takes the big signal that comes from the Earth and breaks it down into smaller chunks called channels. We have the name channels from the old days when it represented one TV channel worth of information. Today, it's not so much TV channel, it could be any sort of digital information, voice, data, whatever. But what the multiplexer does, takes that big band, breaks it into little chunks, allows the satellite to process it, amplify it, and then the MUX puts it back together again to send it back down to Earth. I'm Jeff Weasel, and I'm a proud space nerd.
What kind of communications do satellites provide?
Well, satellites are best known for broadcasting. A single satellite can reach tens of millions of dishes from GEO. Additionally, satellites can be used for point-to-point communication, connecting boats, trains, and rural areas.
How big of an area do the satellites cover?
That depends on the orbit and the antenna configuration, but to give you an example, a geostationary satellite can cover 1/3 of the Earth's surface. A satellite in LEO, on the other hand, would only cover something like 600 to 1,000 kilometers in diameter.
How do the signals going to the satellite from Earth not interfere with the signals coming to Earth from the satellite?
The way the satellites do not interfere with the uplink and the downlink is they're on different radio frequencies. The uplink is transformed aboard the satellite and then retransmitted to the ground.
How do the signals from satellites differ from the signal that I would have here on Earth with my cell phone?
They're remarkably the same. The cell signals actually form spots on the ground that are about 10 kilometers in diameter. The satellite, being much higher in the sky, forms much larger spots on the order of 500 to 600 kilometers. I'm Sid Rao, and I'm a proud space nerd.
And that's how we talk to satellites in space and how they talk back to us here on Earth. Hailing frequencies open. Yeah, you're going to want to take a right at Pluto.